Okay, this is the second video on section 2.3 inequalities. And now instead, how this differs from the last problems in 3 is notice I don't have 0 on the, on the right-hand side. So I can't just jump to sign analysis here. Instead, there's got to be a way for me to deal with this. The temptation is to multiply both sides by x plus 1 and then just solve. The problem is that I don't know what x is, so I don't know if x plus 1 is positive or negative. And remember, if x plus 1 is a quantity that resulted in a negative, you'd have to flip the inequality sign. Oh, so we don't know. So there's 2 ways to deal with this. I'm gonna go through both ways. The first way is something that I do recommend, particularly when there's absolute values in the problem too. I just find it will be easier. But if you like method 2, go for it. That can be fine too. But method 1. All right, so method 1 is the goal of getting to be like problems at the end of number 3, where we use sign analysis. So to do that, I'm going to bring the 1 to the other side, because the goal is to get 0 on one side. So x plus 1 minus 1 greater than or equal to 0. And let's make a common denominator so I can have a single fraction. So the common denominator is x plus 1. Okay, so doing this out, I get combining the numerator, combining like terms, x minus 8 over x plus 1 greater than or equal to 0. And now I can do sign analysis, and 8 is where the numerator equals 0. And remember, because of the equality, I can include the 0 case. The denominator is 0 at -1. That has to be an open circle because it cannot equal -1 because you can't divide by 0. So it could change sign across 8 and across -1. And if I put in values greater than 8, positive. Between -1 and 8 will be negative, and then positive again. And so my solution here, given I want greater than or equal to 0, is -infinity to -1 union 8 to infinity. Okay, let's try method 2. Again, you can always do this method that I just did, which is make a single fraction with 0 on one side and do sign analysis. Method 2 is, okay, what if I don't like working with fractions? And what if I don't like dealing with denominators and things like that? Well, we just said that if we knew x plus 1 was positive, I could multiply both sides and not change the inequality sign. Well, what values of x would make that positive? Well, if x plus 1 is greater than 0, or in other words, x is greater than -1, then I can multiply both sides and be assured by x plus 1 and be assured that I'm multiplying by a positive value. So let's do that. So we've got 2x minus 7. Again, because I know that x plus 1 will be positive, I can just multiply both sides by it. So I've got x plus 1 times the 1 that was over the right side. And then I just solve this, greater than or equal to x plus 1. So x is greater than or equal to 8. But remember, I restricted this to values greater than or equal to 1. So I want to look for the overlap of my solution and my restriction, which in this case will be 8 to infinity. Okay, well, let's do the other possibility. If x plus 1 is negative, or x is less than -1, then I've got to flip the inequality sign when I multiply both sides by x plus 1. So I'm going to have x plus 1 times 1. And notice I flipped that inequality sign. And combining like terms, well, let me just write this. Less than or equal to x plus 1. X is less than or equal to 8. Again, though, I have to go back to my restriction. Well, the most restrictive here, or the overlap of these two things, is less than -1. So from this piece, I'm getting -infinity to -1. And then you just put the two pieces together. And notice I get the same as I did above. One, as always, a goof check. It can be if I plug in infinity or negative infinity, should I expect those to be part of the solution? Well, let's look at that. So if I plug in, actually we can look at it here. If I plug in something huge to the top, say I plugged in 1 million for x, I'd get 2 million minus 7, which pretty close to 2 million, or if you want to put in 1 billion. If I do 2 million plus 1, if I put in the denominator 1 million plus 1, pretty close to 1 million. So you've got like 2 million over 1 million, which is going to reduce to about 2. And the question is 2 greater than or equal to 1? It is. Okay, so I should expect infinity to be part of my solution. If I put in negative infinity, so negative huge, then I'm going to get, say, if I put in negative 1 million, I'm going to get negative 2 million essentially over negative 1 million, which is going to be, because they're both negative, also going to be about 2, and 2 is indeed greater than or equal to 1. So I should expect both positive and negative infinity as part of my solution. Okay, let's look at another here. So the nice thing about, so you see an absolute value and you're like, oh God, absolute value here, which is true because sometimes it can add just another layer of complication. But the nice thing in this particular problem is notice the denominator, absolute value of x plus 3. The good thing is that can never be negative. So I actually don't have to worry about the business of, oh, I don't know if it's positive or negative. It is always positive, then I can multiply both sides by the absolute value of x plus 3. Okay, sorry, got interrupted there. Given that absolute value of x plus 3 is always positive, I can multiply both sides by x plus absolute value of x plus 3 and not have to worry about changing the sign. So let's do that. I mean, we could, if we wanted to play it safe, bring the 1 over and make a common denominator, but again, no need in this case. So if I multiply both sides by the absolute value of x plus 3, again, I can do that because that's always positive. Then I get 2x minus 5 greater than absolute value of x plus 3. Well, the downside is I can't just go ahead and solve that now. I'm still going to have to break it up into 2 different inequalities because I've got that absolute value. So the absolute value changes sign at 0. So I've got the case if x is greater than or equal to 0, I'm going to write 2x minus 5 greater than x plus 3. And the other case is if x is less than 0. Then I have 2x minus 5 greater than negative x plus 3. So you can see the work from absolute values now coming into play here. So solving this left side, I get x greater than 8. And again, looking at the overlap of these two, so greater than 8. So from this side, I'm getting 8 to infinity. And from this other side, I get 3x greater than 8 again, x greater than 8/3. Well, there's a problem here because there's no overlap. So there's nothing from that piece. So the only solution here is 8 to infinity. Again, you could have just brought the 1 over and made a common denominator, but you're still going to have to deal with the absolute value. So you won't be able to get away from that still. Okay, so let us see if there's anything else that I want to go over in this. And actually, I think this is good for now. Let's stop there for now.